Oh gosh, I feel like now I have to measure up to several measures of a love supreme, which is a challenging thing. I could try and sing it for you, but as you can tell, I'm a little sick and it's probably not going to come out well. So artificial intelligence is the greatest technological innovation in the history of humanity. Or it's sort of a giant fraud perpetrated by a couple of big companies to pump their stock prices. It is going to wake up someday and not only play beautiful jazz, but take over the world, be smarter than us, and apparently turn us all into paper clips. Or it will make us all gods. Just this amazing technology will lift all of humanity up. No more worry about rent or food. We'll all be our best selves. There are so many bullshit stories about AI out in the world that it becomes very hard to tell an interesting one that's actually representative of what we're looking at, what the world is going to be like in 10 or 20 years. Partially because the changes are coming so fast, it's very hard to know. But also because people treat artificial intelligence, I think, the same way that they treat stories of demons and angels and fairies. It's just some other thing, some fantasy that we're living in its narrative today. And none of that is very useful. So I've been asked to give 2 talks at the Singularity conference here. One today on AI and one tomorrow about people. And to summarize both of those talks, I would say artificial intelligence is a tool, and humanity is a purpose. And understanding that relationship is incredibly important for understanding what artificial intelligence might mean to you as a business leader, as a policymaker, as a citizen, as a parent. Let me be clear. It is an immensely powerful tool. There are a great many people out there that think, we've been here before, this is all the same old thing. This is not. This is, in some cases, a genuinely frightening tool. It's worth noting it's probably frightening because of what we think other people might do with it than what it itself can do. But that same power means that it truly can do amazing things for us. Ultimately, as I'll lay out in this talk, whatever artificial intelligence and machine learning is, it will always only ever be a reflection of our own ethical choices. So let's start with the definition, because that's how all these talks start. Artificial intelligence, and forgive me, in some ways I'm very boring and wonky. AI is any autonomous system that can make decisions under uncertainty. Is there a giraffe in this picture? What's the next move I should make in this chess game? How fast should I be going as this car makes a left turn? Should I hire this job candidate? How much risk is associated with this data on the spreadsheet in front of me? Should I make an investment or not? Those are all decisions under uncertainty. And typically, we've needed humans to make them. Some of these decisions, virtually all of us can make. Is this face happy, or is it faking it? That's something, and turns out, we're all pretty good at, even though it turns out we're also not very good at explaining why. And AI can now do that. We're about to see an example. On the other hand, there are some decisions that seem really esoteric, challenging. You go to school for years, you get a PhD. So things like being able to do a risk analysis on a spreadsheet, or being able to win a world-class game of Go, that AI can now do vastly better than any human being. And that's complicated. How do I understand all of this stuff? Let's add one additional definition on top of that: machine learning. And again, forgive me if I'm being pedantic to those of you who feel very much in the know, but let's just describe machine learning as an extension of artificial intelligence, where the systems can actually learn on their own how to make these decisions. They can learn through data, they can learn through experience, but they learn. And of course, as you probably have heard, this gives a huge advantage to organizations that have massive data sets, because now you can train up artificial intelligence to do amazing, sometimes superhuman things if you own the data and infrastructure to do it. All right, we've set the stage. Now let's do a little history. But unlike how these talks normally go, I don't care about the rest of the world. I'm a solipsist. I only care about myself. So we're going to do my history of artificial intelligence. So 20 years ago, I was an undergraduate at university, and I was introduced to machine learning for the first time. I thought I was going to be a wet neuroscientist, which is to say jam wires into cats, measure the activities of the cells in their brains, and then I got introduced to this place called the Machine Perception Lab. And they were doing a project for the CIA. Morally gray, yes, but it was so cool. We were training a system. Again, training, not just hand programming. We were training a system how to learn and recognize facial expressions. So we could show it a raw video, it could find the face, read the expressions, and then, of course, what the CIA actually wanted, tell us whether this person is lying or not. Real-time lie detection off of raw video. You can imagine what they want to do with it. I tried not to. So this was just addictive. It was incredibly powerful. I mean, it's so much cleaner. Sticking wires in cats is a very messy business, and this didn't have any of that. So I was totally down with this. This is a much cleaner way to study the brain, is to just build fake ones on computers. So this field is called theoretical neuroscience, and it's awesome. If you want to understand it, just substitute the word lazy for theoretical, and you have a pretty good assumption of what this sort of a person is. We get to study machine learning to study the brain, and vice versa. And this was my introduction. You're seeing a demo up there of a real-time system done by the startup that spun out of that lab. So we tried really hard 20 years ago. It was massive funding from the CIA, dozens of dissertations. It was incredibly hard work. We made progress, but it was still a bridge too far. The lab spun off as a startup and kind of trickled along for a little while. And then this new technology called deep neural networks came out. And the technical details really don't matter. If you want to understand deep neural networks, then go watch Andrew Ng's course on Coursera, or better yet, go take a course on probability theory, because that's where you should start. Simple to say, it is making models very, very large. They can grasp massive sets of data. And in this case, the performance of the system jumped enormously. It went from an aspiration to something that could truly work in real time, easily. They were still struggling as a startup, but they had this very clever idea. So about 3 years ago, it's the run-up to the US presidential elections. This is the primary system where the Republicans and the Democrats are each running their own campaigns, and they have these big debates. And in one of those debates, there's like 157 people on stage, and all of the Republicans running for office, and everyone's really wondering one thing. Back then, it really wasn't about Donald Trump. It was whether this guy, Ted Cruz, actually had any human emotions. So the startup had this clever idea. They ran a real-time analysis on the facial expressions of all of the candidates. And then they just showed it on YouTube in real time. So you could watch whether they were happy or sad or lying in real time. And again, this is a demo here. This is one of the founders of the company displaying how the system works. And very literally, the next day, the bidding war started between Facebook and Apple. So if any of you here have an iPhone 10, all of that fancy face recognition technology that runs on top of it, that's my old undergraduate lab. It powers all of that, including the animojis you can see being displayed up there, little cartoon faces that you can talk into your phone and it would transmit. We talked about doing that 20 years ago. All of this was there, all the capabilities, but we were never able to make it real, including real time, the way it is now. And in fact, that slide there is it. That is everything that exponential innovation will ever have to tell you. It is tens of millions of dollars of CIA funding, 20 years of research, dozens of dissertations to animate cats on your phone. That's it. That's all innovation everywhere will ever become, is animated cats. It's worth knowing that before you get into it. I don't care what field it is. It could be computational genetics. You're going to animate cats in the end. But it's worth noting that this is a perfect example. We did something that was esoteric. It was academic. And we took it all the way into something which is now given away for free on your phone. Something powerful. Recognizing facial expression, recognizing people, something that only human beings could do for hundreds of thousands of years of our existence, probably longer than that. And now we have automated systems that can do it instead. Here's another little personal story, and I'll keep this one a little brief. This is my son, not the president, but the other one. Although I am quite fond of the other guy. So 7 years ago, my son was diagnosed with type 1 diabetes. So this is an autoimmune disease where your own immune system wipes out the cells that make insulin. So you can eat all you want. The sugar builds up in your blood, and you still starve to death. It's a terrible disease. Until about 100 years ago, when they developed the ability to extract insulin from, at the time, I think, from pigs, and then just inject it. And suddenly it's a transformation. Still a terrible chronic disease that kills people on a regular basis. It was a hard experience. But what's even harder is my wife and I, we're both scientists. So when we get home from the hospital, we start collecting everything, every bit of data about our son. How much did he eat to the gram in protein, carbohydrates, and fat? How active was he? We put all sorts of trackers on him, insulin pumps, continuous glucose monitors, sweat sensors, heart rate, everything. We collect so much data you can't believe, because I was going to really impress his doctors. So we took all of this, a printout spreadsheet, an inch thick of paper, into the doctor's office with us, thinking, they're going to love us. Well, turns out they were quite unhappy with us. How dare you waste our time? What am I supposed to do with all this data? More to the point for tomorrow's talk, if you ever use that phrase in your day job, what am I going to do with all this data? Your job is not long for this world. But in that moment, you certainly understand that doctors and nurses weren't trained to just take a massive data and somehow integrate it into their predictions, into their diagnoses and prognoses, into their treatment plan. So instead, they gave us a little sheet of paper, and they asked us to handwrite 15 numbers. 5 days, breakfast, lunch, dinner. We had 15,000 numbers. I thought to myself, and forgive the foul language, this is me, and it was my actual thought at the time, you have got to be fucking kidding me. I make models of the brain. Are you telling me diabetes is more complex than the brain? That's nuts. But it was the way it was done. So, as we left the doctor's office, we bought a book on endocrinology, and the next morning, I hacked all of his medical devices, and we built the first ever artificial intelligence to treat diabetes. It was interesting. I mean, it was wonderful for us as a parent to be that person that could actually make a difference in your child's life. But it is interesting. It's a multi-billion-dollar industry. Plenty of companies out there competing, building new technologies. Why was this weirdo mom the first one to ever build a machine learning system? Now, it was a while ago, before the current craze for artificial intelligence has come on, but it was also because people didn't understand what was there to be learned. We know everything about the biophysics of insulin. We know everything about the biophysics of digestion. There's nothing to be predicted. There's no value to be added. But what you understand, once you start building these systems, machine learning, artificial intelligence applied to massive data sets, is there's always a story. Hidden in that data is a story. It could be the through line of a riff in jazz. It could be the nuanced story about how people recognize faces differently. In this case, it was the story of a little boy who'd wake up early one morning and he'd sneak in and eat a little food before he got his insulin. His blood sugar would go up, and then it would push back his lunch, and he'd have a low blood sugar in the afternoon because of mismatched dosings. And it turns out that story would echo over days. It wasn't about biophysics. It was about a human life. And this is where artificial intelligence gets exciting, where you can use it to understand people's lives. It's also where it gets powerful and where it can get scary. But this was an amazing thing. So I got to build this thing. I actually wore Google Glass every day for 3 years, way longer than anyone at Google ever did. After a little while, it gets to be a drag as you walk past people and they say, glass hole. So I did, however, and the reason I wore it is I built myself a superpower. You want people to use cutting-edge technologies? As my very simple way. I have founded 5 companies. I've been a founding executive at several others. Every time I go into a new space, I'm there to build a superpower. Something that a human fundamentally could not do on their own. Anything else doesn't interest me. So I built myself a superpower. This AI that could treat my son's diabetes. And it sent me real-time messages to my Google Glass. Want me to wear a fluorescent blue computer on my face all the time with a little camera on it, if you didn't know what it was? That's how you do it. In fact, I was so addicted to it, I wore it to a party at the White House. That is the only presidential portrait ever taken with Google Glass. He wanted to meet the crazy lady that violated security protocols so that she could have a live camera in the White House on her face. Interestingly enough, by the way, we were able to get back to the idea that it's what we do with it that matters. You're able to take the same algorithms that we developed to understand how people perceive faces and expressions and build it into Google Glass for autistic children. Turns out one of the most common symptoms of autism spectrum disorder is an inability to read facial expressions. So if you build it into this, by the way, the state of the art for training them, it's not computers, it's cartoon flashcards. This one's smiling, it's happy. This one's frowning, it's sad or angry. And that's how they would learn. And you could learn, it's like a second language. We get it for free, but they don't. Well, it turns out, when you build it into Google Glass, using the AI to do the actual recognition, and then write the expression on the screen, or just use a little emoji and exaggerate it, not only is it prosthetic, which is to say, it allows them to recognize it even if they could never learn. They can learn, and they learn better. And in fact, they learn something else. Another common symptom of autism is a lack of empathy, the inability to understand why other people do what they do. So we built this system and we tested it, and not only can the kids learn how to read facial expressions even better, they learn empathy. I mean, you think about it, maybe it's not so surprising. Because what does a cartoon flashcard lack? It lacks a story. It's just happy or it's sad. Not because, it just is. But when you learn how to read expressions by interacting with other people, there's always a reason. And you can learn that. They can learn that. This is a perfect example of where this very scary technology that wants to take over the world, supposedly, is in fact a phenomenally human technology, if we choose to use it that way. And in fact, I would summarize what AI is capable of at some point with a slide change that is going to happen someday as the following. Forget the definition earlier. It's a good wonky first-order definition. For the sake of understanding artificial intelligence in your organizations, AI is any brief, expert human judgment made faster, cheaper, and increasingly better than a human can make it. And it's worth understanding now what that means. Where does it take us as a technology? We'll try this again, and again, and then we'll wing it. All right, so there's something going on with the slides, but that's okay. What's important here is that there are a lot of stories out there about what AI is capable of and what it can do. In fact, one of the best that's caught a lot of attention is Alphago, and then a lesser-known case called OpenAI 5. So Alphago is a system built by DeepMind, the subsidiary of Google, that learned how to play Go. And in learning how to play Go, it defeated the best Go players in the world. And then DeepMind developed a system called Alphago Zero that taught itself how to play Go, just played against itself, and then beat Alphago 100 times in a row. Talk about superhuman performance. This system trained itself in about a day to be so superhuman that it defeats the superhuman AI. Now, stories like that may sound very daunting. Where is a human future in a world in which these systems can do so much more than we are capable of? But it's worth understanding a few things. AlphaGo doesn't understand Go. Even while it beats the very best players, it doesn't actually understand anything in the way we would consider understanding. How do you know? Well, sometimes the easiest way is to look at the errors systems like this make. Pictures that have a bicycle in it, and it says it's a raccoon, and you think, does this thing not understand anything about what a bicycle actually is? Well, yes, that is exactly the case. These are massively powerful tools that can outperform the best people while, amazingly enough, still not actually understanding what they're doing. So why do they perform so well? Actually, the OpenAI 5 is an interesting case. So there's this game out there, I think Halo is the one, but it doesn't really matter, a computer game, as I call it, a first-person shooter. You go out, you have the perspective, you run around, you kill a bunch of other people. That's the game. And in fact, you can play it in teams. So in one case, they have a big tournament where they have teams of 5 separate players. So OpenAI is a nonprofit based in Silicon Valley that does artificial intelligence research. And the ideal is, of course, to do it outside of the confines of a corporate ownership, share it with everyone. So they built this system, and they trained not 1, but 5 independent AIs to play together on a team. And then they went into a tournament, and they beat some of the best teams in the world. Now, that's very impressive. And part of understanding why these things perform so well is to note that every day that OpenAI 5 trains is essentially the equivalent of about 125 years of human gameplay experience. So it also doesn't make mistakes. Thank you. It also doesn't make mistakes. There we go, and we're going to catch up here any moment. So it's not that it needs to train just to hone its skills and stay competitive. Once it has a certain performance in place, that's what it does. So instead, once it learns the basics of gameplay, in a sense, you can think of it, it spends the next 100 years exploring all the possible ways you could play this game. In fact, it's very designed. It's called the exploration-exploitation trade-off. It is designed to maximize how much it can learn. Same is true with Alphago. So in fact, one of the reasons these things perform so amazingly well, at least first time, against human competition is, unlike the human player, who may have spent their entire life, but remember, that's much shorter than the AI has ever played the game. They have explored all these possible alternatives. They also don't have any preconceptions. So the metaphor of the game, if they find all the bugs in the system, because all they're trying to do is exploit getting the most points. And it's really fascinating to understand that these things are totally naive. They don't know anything about the world. They're crunching a massive number of parameters and maximizing a score. And they will do anything and everything to push that forward. And the output is something amazing, something superhuman. But it's always worth understanding the edges and the difference between how these systems perform and our own understanding, because then it can lead us to make some weird judgments. So here's two sets of possible jobs someone might have in the world. Up top, you might have someone working in agriculture, out in a field, picking strawberries, or serving food at an event, handyman. You could throw in a warehouse worker, moving boxes around, or a driver for that matter. Down below, so those first sets of jobs, relatively, we might call them low skill. They're certainly low pay. People doing those jobs do not have much in the way of negotiation power for much of anything. Down below, though, we have these incredibly desirable jobs. Reading spreadsheets, financial analysts doing risk analysis, lawyers reading contracts, software developers writing code, doctors looking at x-rays. So you look at those two things and you think, well, AI is getting really smart. So surely it must be ready to do all those low-skilled jobs. But me, with my job as a highly paid financial analyst, I'm safe, right? No, actually, frankly, it's the exact opposite. Turns out those low-skilled jobs are really hard for a variety of reasons, not the least of which is virtually all of them require building a robot to carry something out physically in the world. And it turns out picking strawberries is just a very, very hard task. We may not think of it as hard because we can all do it. But it's very challenging. You have to completely rethink what it means to have a farm. So people are solving this problem. They're re-envisioning a strawberry farm as raised hydroponics where the strawberries hang down. The entire thing is a factory line. The robot doesn't need to go. It's not a robotic field worker. It's an entire robotic farm, transforming the idea. But the actual job itself that exists in the world is not very automatable, not easily. Those jobs on the bottom, they are about to get blindsided. Every one of those. There are hundreds of startups building AIs to do 80% of those jobs for essentially no cost relative to human capital costs. Now, if you're the CFO of a major corporation, you know what your choice is. Get rid of the people, replace those jobs with these systems. They're powerful. They do it cheaper, faster, and often better than humans can do it. Why wouldn't you make that choice? And if you think I'm just being a rabble-rouser, one of my favorite examples of this is a competition that was recently done at Columbia University between a startup that had developed an artificial intelligence to read contracts, looking for loopholes, and human lawyers. In this competition, they used non-disclosure agreements that had been engineered with a bunch of loopholes in them, and the AI found 95% of those loopholes. The human lawyers found 88%. It's whatever, they're only human, so we'll call it a tie. The actual difference is that the human lawyers took 90 minutes to read each contract, and the AI took 22 seconds. So I'm willing to bet many of you have a job a little bit like this. That may feel very uncomfortable. Now, let me be clear. Again, the AI doesn't understand the contracts that it's reading. It's simply been trained to take this input and spit out that output. It can make weird errors. But in terms of average performance, it beats humans. What do you do with those loopholes? Well, that's still us. We still need to make those decisions. But in thinking about what AI is in the world, any human judgment, cheaper, faster, and better than a human could make it, that is a perfect example. And if you're a lawyer, you've got to be thinking right now, if 80% of how I spend my time reading contracts, doing case prep, doing review, can be done virtually for free in a few minutes, will my boss keep me on staff? Or if you employ these people, do you keep them on staff? We're going to talk more about that tomorrow, but let me say one thing as the last person in the cell there doing the programming goes, the solution to this problem is not teaching people how to program. That we can save the magical thinking for some other life. There's a bigger, deeper solution to this. But so I already talked a little bit about Alphago and OpenAI. They're really fascinating tools. But this is where we're starting to move from where the world is right now to where we're going next. There are a huge number of really cool examples I could give you. I'm a geek, so I love talking about the sciences, using artificial intelligence to discover new exoplanets, using it to map out our genomes in exquisite detail. One of the coolest recently was being able to actually map out a whole biome just by looking at the genetic material left behind in streams. So you could just sample things out of a stream and recreate what the biome upstream must have looked like. Truly fascinating stuff. But again, I'm totally self-obsessed, so I'm going to talk about some of my own work in hiring. I've already talked about this idea, but here's a good example of it. So recently, Amazon had a news story come out that didn't make anyone at Amazon very happy. They had developed a deep neural network to analyze all of their hiring history information to try and predict who they ought to hire next. And after several years of working on this, they discovered that it was unfixably sexist. If a resume even had the word women's in it, it was downgraded. And I will say, since I am far and away the smartest person in the room, that's always a terrible idea. Sorry. They tried all the standard fixes to make this work. They went back and they fiddled with the training data. They put all sorts of filters on top of the AI. They did everything they could think of to fix it, and nothing fixed it. So here's the funny thing. About 3 years ago, Amazon asked if I would be their chief scientist for people. And this would have been exactly one of the projects I would have worked on. And I told them back then it wouldn't work. One of the things that's worth knowing about deep neural networks, machine learning, and modern artificial intelligence is because it learns from experience, that experience defines what it's capable of. What do you imagine the hiring history of Amazon is like? It's probably a little biased. It's probably very male, probably very white. Is there any surprise that if you train up this AI that doesn't actually understand anything about what makes a great employee, all it knows is, I have all of this training history, and these are the people that got hired and did the best in the company. And so it learns what it learns. And in the end, they had to drag it around behind the barn and shoot it in the back of the head, because the whole thing was a massive failure. But again, they could have known it ahead of time. And it's not trivial for me to say that, because I had a company that preceded Amazon. It was the whole reason they tried to hire me. I was the chief scientist at a company called Guild. We were doing exactly this, AI for hiring. Our tagline was, we take bias out of the hiring process. And we didn't do it anything like the way Amazon was approaching it. And so here's where I'm going to be a little cantankerous and get outside the typical AI story. As amazing as it is, we can do better. There are principles at play that don't exist in modern artificial intelligence, and they must. They must for us to turn the corner and go beyond what we've done today. These truly amazing technological systems that can take a massive data and turn it into an autonomous decision, they now need to understand the world and what that means. So, for example, at Guild, I had never worked in higher, I've never even had to interview for a job in my whole life. What do I know? I'm a neuroscientist who had started a couple of education companies. I don't know anything about hiring. So I did what any scientist would do. I read 100 years worth of research about what makes a great employee. I didn't get a hold of a massive data, although we did have a data set of 122 million people. Instead, we built little AIs that looked for the things that science had proven was causally related to great job. Resilience and empathy, strong cognitive abilities, again and again, all of these factors, little AIs. Now imagine, we could still do this out in the real world. I'm not saying that this is easy. These AIs had to go out through people's Twitter feeds, read their LinkedIn profile, analyze their blogs, and come back and say, I think this person's resilient. That is hard work. That is something that requires expert human judgment. We were able to build that, but we knew that if we learned it, that was causally related to someone being good on the job. Right now, deep neural networks are purely correlational, overwhelmingly so. So you never really know whether what it's discovered is the true story of the way the world works, or it's just a correlation between a bunch of data. And the word women's tends to correlate with work job performance. Well, that's maybe because you don't hire women very much. And so let me call out 3 principles that I think will be the defining characteristics of the next generation of artificial intelligence. That they are naturalistic, closed loop, and causal. So what does naturalistic mean? The best example is a system I built that could take data off your mobile phone. You didn't have to do anything. It wasn't a survey. There was not any special test that was done. It just grabbed passive data off the mobile phone, and it was able to predict 3 to 4 weeks ahead of time whether people were going to, bipolar sufferers were going to have a manic episode. 25% of severe sufferers will go on to kill themselves. We were able to build this system on the phone that just watched them live. We built another system for students that could listen to them talk to each other. Instead of chatbots, we called it a listen bot. And this was 10 years ago. We would listen to university students just talk to each other online. We knew how they would perform in the course on week 1. We knew what they'd get wrong or right on a standardized exam increasingly accurately as the weeks went on. We were trying to end the test. We could make the assessment natural, or naturalistic as it comes out of the language of neuroscience. So one of the things we want is AI that works out in the world. Now, that is increasingly true. The Internet of Things is a terrible concept, but the idea that there are rich sensor sets out in the world that these systems can collect information off of and do powerful things is real. And if we invest in making these systems work with that messy, ugly, real-world data, then we stop building biased AIs that think the world is pretty data sets when the world is actually you. And you can build things like this that can predict manic episodes and prevent suicides. The next is closed loop. This also comes from my life as a neuroscientist. I'm going to talk about this in just a moment, but if you want to build what are called neuroprosthetics, systems that can actually interact with the brain, you have to build a closed loop where your computer and the brain and the external world interact. go tonight and Google BrainGate and watch the YouTube video of a woman reaching out, picking up a thermos, and taking a drink of coffee. Because that woman is profoundly paralyzed. She's imagining she's moving her arm, but she's actually moving a robotic limb. And again, this is like 12 years ago. That's a closed loop. Her eyes are observing the arm moving, and her brain and the computer interface are interacting with one another and updating in real time. We build a system, another one for little kids. It learns about them. It's closed, it interacts. So every night it learns a little bit about kids, and then it sends an activity home to their parents. Tonight, do this with your child. It will have the biggest impact on their long-term outcomes. And then the next day, we measure the impacts, and we keep going and going. No big, massive data sets, naturalistic data, and a closed loop. Every night, it runs thousands and thousands and thousands of new experiments and learns. And what it learns is causal. So it learns that this experience in these kids changes them in this way. Is it truly causal in the way that a fully controlled experiment is? No, but it turns out the entire field of economics is based on exactly such causal reasoning. What can we reasonably infer from the world? These three things, built into modern artificial intelligence, will transform its ability to interact with the world. It already has superhuman performance, but only in domains which never change, which have masses of data, a lot of economic value. Those exist. Those are your jobs. But if you want to go to the next step, if you want to think, how do I build a system that not only recognizes loopholes in contracts, but knows what to do about them? How do I build a system that can not only recognize that someone is happy or sad, but actually understands what that means, that it has empathy and perspective taking? These are the next steps, and they're already being taken. I'm very selfishly talking about my own work here, but here's an example from a joint group at Google and DeepMind of a paper they have. I'm not going to explain it, but they're looking at combining graphical models, which is another field of artificial intelligence, with deep neural networks, and putting them together in one. Because as they put it, as I agree with, we already know so much about the world. Why do we pretend like we know nothing when we build these machine learning systems, when instead we can build that knowledge right into it, and it can learn so much more and so much more richly about the world? So this has been an unusual talk on AI because I'm supposed to come up here and just pound you guys with 100 examples of mind-blowing uses. And I hope you saw a couple, but in fact, I want you to think about what comes next. I want you to think about how these systems are used inside your organizations. And this is the big next step. But it's not the biggest next step. One of the biggest questions I get asked about artificial intelligence is, will it ever be smarter than we are? And I have two answers. One is, theoretically, yes. There's nothing in my experience that would prevent us from building what's called artificial general intelligence. Artificial intelligence that's smarter than we are. But no one has invented such a thing. Nobody. And one of the misconceptions, even amongst AI researchers, is if we just build it a little bigger, if we just add a little bit more information in, eventually it will wake up and it will prefer socialism over authoritarian. I don't know, but it'll have some preferences about the world. No, none of that will happen because our current systems lack the three things I noted earlier, amongst other things. However, I can give you a rough timeline from when we will have people that are artificially smarter than other people. So this is called cognitive neuroprosthetics. And I have a bit of a sham example here, although I have 3 applied neuroscience companies out in the world right now. This is the mashup of the best of what machines can do and the best of what humans can do. And in this conference, you're going to hear more about these sorts of advances. But one of the most exciting is a company where you flip a switch and your working memory, your raw cognitive capacity, goes up by 15%, which is the equivalent of earning $15,000 to $30,000 a year more in your life. You literally live longer. This is profound change in the very definition of what it means to be human. And it has all the same ethical implications of AIs that are smarter than we are. And it's coming. It's already happening today. So all the things we've been thinking about here is just a setting. Artificial intelligence is an enormously powerful tool. It's what we choose to do with it that actually matters. And it's the next set of advances that will transform us from a world where we can automate away contract review and basic programming skills into a world in which the AI and the human is a fundamentally ambiguous distinction. And we're almost there. All I will say is my approach to all of these problems is to always and only ever use these systems to make people better. But that's a choice that's in front of us. Do we choose to improve humanity, or do we choose to replace them? It's a big choice. And if it's your company and your bottom line, it's a lot harder choice than you may appreciate. But it's there. And tomorrow, we're going to talk about its implications. So thank you very much.